ఓకే, ఇవి కాంబినేషన్స్. ఇక్కడ షిఫ్ట్ ఆపరేటర్ ఈజ్ డిఫైన్డ్ యాజ్ అని ఇలా ఇచ్చాడు. దెన్ డెల్టా ఫార్వర్డ్ ఇన్ ద టర్మ్స్ ఆఫ్ ఈ అని ఇచ్చాడు. దీనికి ఆన్సర్ ఫార్వర్డ్ డిఫరెన్స్ ఇన్ ఆపరేటర్ డెల్టా అనమాట. ఎఫ్ ఆఫ్ ఎక్స్ ఇస్ ఈక్వల్స్ టు ఎఫ్ ఆఫ్ ఎక్స్ ప్లస్ హెచ్ అండ్ మైనస్ ఎఫ్ ఆఫ్ ఎక్స్ అండ్ షిఫ్ట్ ఆపరేటర్ this is and so on. How many diagonals can be drawn by a joining angular points of an octagon? 20 అనమాట. దీని ఫార్ములా ఏంటంటే n into n minus 3/2. So we have a polygon vertices of each vertex of total n into n minus 3 by the joining vertex of then every other vertices accept neighbors. So the total number of diagonals is equals to n into n minus 3/2 dividing 2 because we are counting each diagonal twice. For the example, diagonal contraction, third vertex and fifth vertex is continued with respect to the both vertices, and n is equal to 8 for octagon. Number of diagonals is equal to 8 minus 3 into 10. 8/2 is equal to 20. And the sum of the infinity series 3x square 3 plus 6x square plus 9x power 4 దీన్ని ఎలా చేయాలని ఉంది. 3ని కామన్ తీసుకోండి. ఫస్ట్ 3ని కామన్ తీసుకోవాలి. ఓకే, ఇక్కడ ఉంది. ఫస్ట్ 3ని కామన్ చేస్తే 1 2 3 4 5x అని వస్తుంది. ఈ సిరీస్ని 1/1 minus y whole square అని తీసుకుంటాం. అదే ఇక్కడ ఎక్స్ వస్తే 1/1 minus x square అన్నట్టు వస్తుంది. సో ఇది అనమాట ఆన్సర్ కాంబినేషన్స్. అండ్ గ్రాఫ్ 3 a graph with n vertices and n minus 1 edges that is not a tree is disconnected. And answer a graph with n into okay, ఇక్కడ చూడే గ్రాఫ్ థియరీ విత్ n disconnected. దాని ఆన్సర్ ఏంటంటే గ్రాఫ్ విత్ n vertices and n minus 1 edges that is not a tree is disconnected and contains a cycle as well, because if the given graph is a tree, neither disconnecteds nor cycles are allowed. Within the help of n minus 1 edges, we can create a tree of n nodes. If we don't want this result of to be a tree, we have to be isolated one node at least, which leads to disconnectivity. For that, we need to create a cycle in a remaining component. If a graph requires k different colors for its proper coloring, then chromatic number for the graph is k different proper coloring k anamata chromatic number. A chromatic number of graph is the smallest number of colors needed to the color vertices of, so that the no two adjacent vertices can share the same color, and the graph requires k different colors for its proper coloring, then k is a chromatic number of the graph. Let x be the adjacent matrix of the graph with no graph G with no self loop that enters along with the principal diagonal of x or all zeros. ఇక్కడ థర్డ్ ఏంది, an adjacent matrices of a graph G is the diagonal entries shows that the connectivity with themselves. Since the graph G has no self loops, all these enters should be 0. Okay. The number of distinct simple graphs with up to 3 nodes is 7. ఫోర్త్ దానికి ఆన్సర్ ఏంది, ఇక్కడ ఫస్ట్ వర్టెక్స్ 1, 2 వర్టెక్సెస్కి ఇక్కడ ఒకటి గీసినాం, ఇవి రెండు వదిలేసినాం. 3 వర్టెక్సెస్కి ఇక్కడ ఒకటి ఇలా ఉండొచ్చు, ఇలా ఉండొచ్చు, లేదా ఇలా ఉండొచ్చు, ఇలా ఉండొచ్చు, ఇలా ఉండొచ్చు, ఇలా ఉండొచ్చు, ఇలా ఉండొచ్చు. ఇది పాసిబిలిటీస్. అంటే మొత్తం అన్నీ కాకుండా అన్లేబుల్డ్ గ్రాఫ్స్ ఆర్ 7 అన్లేబుల్డ్ గ్రాఫ్స్ ఆర్ పాసిబుల్. ఇవి అన్లేబుల్డ్ గ్రాఫ్స్ 7 పాసిబుల్ అయితే 4కి నెంబర్ ఆఫ్ 3 పాయింట్స్. అది కన్సిడర్ ద ఫాలోయింగ్ షో విచ్ ఆఫ్ ద ఫాలోయింగ్ ఈజ్ వ్యాలిడ్ స్ట్రాంగ్ కాంపోనెంట్స్. ఇటు నుంచి ఇటు వస్తే దీని నుంచి దీని నుంచి ఇక్కడికి రావాలి. ఏకి సికి డిస్టెన్స్ ఇలా వెళ్ళడం వల్ల తగ్గిపోయింది. అండ్ ఏకి ఏ అని అనుకుంటున్నాను, ఏబిసి. సో ఏబిసి అనేది కరెక్ట్ పాత్ అనమాట. ACD is not a valid strong component. There is no path between A and C. ABD is not a valid strong component. There is no path between B and D. BCD is not a valid strong component. There is no path between B and D. And ABC is not a valid strong component. There is no path between every pair of the participants. Is a valid strong component. There is a ABC is a valid strong component. There is a path between every pair of vertices. The seventh one. If G is a graph with the 6 edges and n is the vertices of the sum of the degrees of all vertices is G is 2e. Since the given gap is undirected, every edge contributes 2 to the sum of degrees, so the sum of the degree is 2e. Eighth one, let the G be an arbitrary graph with n nodes and k components. If a vertex is removed from G, the number of components in the resultant graph must necessarily lie between k minus 1 and n minus 1. Eighth one, if the number of component is k, if a vertex is removed from graph, the lower bound on the number of components is the resultant graph is k minus 1. It happens when one of the component is an isolated vertex. One of the vertex is equivalent to the component is removed. If the number of nodes is n, the upper bound of the number of components k is n. The number of components is n when each node in the graph is considered as a separate component. K is less than or equals to n. If a vertex is removed from a graph, the upper bound on the number of components is the resultant graph is n minus 1. One vertex which is equivalent to one component is removed. Ninth one, a graph in which all nodes are the equal degree known as regular graph. A regular graph is the degree of the each vertex is equal. A graph is called k regular if the degree of each vertex in the graph is k. 1 2 3 4 అంటే దీనికి సేమ్ అన్నిటికీ సేమ్ వర్టెక్సెస్ అంటే అది రెగ్యులర్ గ్రాఫ్ అనమాట. ఈ గ్రాఫ్ ఈస్ కాల్డ్ ఎస్ నాన్ రెగ్యులర్ గ్రాఫ్ if the degrees of the vertices are not equal. If the mathematics scale more setly in the graph theory, a multiple graph is known as a which is permitted have a multiple edges, so also called as parallel edges. If there are edges that have been same and n nodes, thus two vertices may be connected by the మోర్ దాన్ వన్ ఎడ్జెస్. ఏ వచ్చేసి బీకి, బి వచ్చేసి సిసి నుంచి ఇక్కడ దీనికి 2 దీనికి 2 దీనికి 2 దీనికి 4 దీనికి 1 దీనికి 1 దీనికి 2 ఇన్ ద సింపుల్ వర్టిసెస్ అని మీన్ ఇంత అవసరం లేదు. దీనికి k2 దీనికి 2 దీనికి 2 దీనికి ఇది k3 అంటే 3 పాయింట్స్ మధ్యలో 3 ఎడ్జెస్. k4 4 పాయింట్స్ మధ్యలో ఇటు k5 k6 k7 నాకు అర్థం కాలేదు. వీడియో ఇచ్చి హెల్ప్ చేసిన నాకు చదివి. 10th one, if the graph G is there is one and only one path between every pair of the vertices, then G is a tree. 10th one, see and walk. A walk is a sequence of a vertices at the edge of the graph. If we traverse a graph when we get a walk, note vertices and edges cannot be repeated. Circuit traversing a graph such that no an edge is repeated, but vertex can be repeated and it is closed. That is a closed trial. Vertex can be repeated, edge cannot be repeated. Path, it is a trial in which neither vertices nor edges are repeated. Vertex not repeated, edge not repeated. Reconnected maximally acyclic graph. Let G be a graph and there be exactly one path between every pair of the vertices in G. So G is connected. G should not have a cycles, because if G contains a cycle, say between vertices, there are two distinct paths between those two vertices, which is a contradiction. Thus G is connected and is without cycles, therefore it is a tree. A simple graph, without parallel edge or a loops with n vertices and k components can have at most n minus k into n minus k plus 1 divided by 2 edges. The graph with n node and k components can have maximum number of edges. Then k minus 1 isolated vertices are considered as k minus 1 components, and remaining n minus k minus 1 vertices from a single component with the maximum possible edges. If we have v vertices, maximum number of edges is equals to vc2 NCR law. Since we have n minus k minus 1 vertices in a single component, the maximum number of edges is equals to n into n minus k minus 1 c, it is equals to n minus k into n minus k plus 1 divided by 2. So idanamata, how many edges are there in a forest with the v vertices and k components? Number of edges is equals to v minus k. Simple. Forest గురించి గుర్తుకొస్తే ఇది రావాలి నీకు. A forest is a disjoint union of trees. If the forest has v vertices or components, k components, the number of vertices in each component is v minus vi. The number of edges in the component is equals to vi minus 1. Because number of edges in the tree with n vertices is n minus 1, the sum of edges of all components summation I is equals to 1 to k vi minus 1. I is equals to 1 k v of minus and sum of all vertices is v, so that its components are so simple ga v minus k ante. 13th one, the number of edges in a n vertex complete a graph is n into n minus 1 by 2. 13th one, a complete graph is a simple undirected graph with the maximum number of edges possible. If there are n nodes, we can pick any of the two nodes to draw a line. So maximum number of edges in n node undirected graph without self loop is equal to the number of different pairs of the nodes that can choose from n nodes. nc2 is equals to n into n minus 1 by 2. తర్వాత 14th, the cube of one unit is placed in such a way that so the origin coincide with one of its tops vertices and the three axes running along its edges. What are the coordinates of the vertex which is diagonally opposite to the vertex which coordinates are 0, -1, 0. వాడు ఏమన్నాడు, లైక్ ఇట్లా ఆరిజిన్ ఉంది, అది కోయిన్సైడ్ అవుతుంది టాప్ దాంతో. ఆరిజిన్ అంటే ఈ పాయింట్ కోయిన్సైడ్ అవుతుంది, అప్పుడు 0, 1, -1 వచ్చేసి డయాగ్నల్గా ఆపోజిట్గా ఉంటాయి. ఐ మీన్ 0, -1, 0 అండ్ 1, 0, 1 అనేది డయాగ్నల్గా ఆపోజిట్గా ఉంటాయి. అదే వాడు అడిగాడు. ఈ 1, 0 కిందకి డయాగ్నల్గా ఆపోజిట్గా ఉండేది ఏది అన్నాడు. In the given connector G is an Euler graph if and only all vertices G are of even degree. 15th one, a graph containing a Euler cycle is called Euler graph. A given connected graph G is an Euler graph if and only if all the vertices of G are in even degree. Euler graph cycle ante an undirected graph has a Euler cycle if the only two coordinates are met. All vertices with a 0, non-zero degree are connected with. We do not care about the vertices with 0 degree because they do not belong to the Euler cycle or path. All vertices have even degree. Euler path, an undirected graph has Euler with the path if the following two conditions are met. All vertices with a non-zero degree are connected. We do not care about the vertices with 0 degree because they do not belong in the Euler cycle or path. If the 0 or 2 vertices have odd degrees and all other vertices have even degrees, not all the one vertex with the odd degree is not possible, and an indirected sum of all degrees always even in an unidirected graph. A graph with no edges consider Euler because there are no edges with the traversant in the Euler path. Each time we visited the vertex, we can walk through unvisited edges with the one point as v. Therefore, all middle vertices in the Euler path must have even degree for Euler cycle. Any vertex can be in a middle vertex. Therefore, all vertices must have even degree. 16 maximum number of edges in an n node undirected graph without self loops. n into n minus 1 by 2. The completed graph is a simple undirected graph within the maximum number of edges possible. If there are n nodes, we can pick any of two nodes to draw a line. So maximum number of edges in an n node undirected graph without self loops is equal to the number of different pairs of nodes that can be chosen from n nodes. N by nc2 is equal to n into n minus 1 by 2. And 17th, the number of edges in a regular graph is a graph of a degree t and vertices v is maximum of n and t. I mean, so it's nd by 2. 17th one answer, and as a very vertices has degree t and the sum of the degrees is equal to n into d. We know that 2 into number of edges is equal to sum of degrees. So 2 star number of edges is equal to nd. The number of edges is equal to nd by 2. తర్వాత సెట్ థియరీ. ఒక సెకండ్.